All right, here we go. We are factoring. Okay, these are quadratic functions, and we're going to be factoring them. All right, there's three different forms of factoring that we're going to be going over. The first one is when it's in basic structure, where there's no number in front of the variable, and it's just set up in this. Okay, so what you're thinking is, what two numbers multiply to make 24, but when you add them, they make a 10. Okay, so you've already probably thought, oh, that's 6 and 4. That is correct. So now I'm going to write it in its reverse form. That's 6 and that's 4. Okay, this is also a correct answer, so don't freak out. All you're thinking is the two numbers that multiply. Now, remember that this is positive, which automatically means that these two signs are the same. Okay, and if this is positive, that means that the biggest number of the two numbers you find is positive. Okay, so if both of them are the same and one of them is positive, that automatically means that both of them are positive. Okay, let's try another one with a little bit of a change here. What two numbers multiply to make 63, but when you subtract them, they make a 2? Okay, so while you're thinking, you know that's a G, you know that's a G. This is a negative sign, which means you know one is a plus and one is a minus. This is a minus, which means of the two numbers we choose, the biggest number is going to be a minus. Okay? So the two numbers that multiply to make 63, that when you subtract them are equals 2, is 9 and 7. So the 9 is the biggest, so it goes with the minus, because that's a minus. And the other one's a 7. And there you go. All done. Now these next ones here. Here we go. Now we're going to do the same thing, but at the end, we have one extra step. We have to solve for 0. Now you could solve 0 here, but it'd be a lot of guessing checking. Right now, let's really quick think of two numbers that multiply to make 42, but when you add them, they make 17. All right, so we're thinking, I'm thinking 14 times 3. Okay, 14 times 3 makes 42, 14 and 3 makes 17. So here we go. So x plus 14 and x plus 3. Okay, pretty easy. All right. I also think, let me see, if we switch these two numbers, 40, no, it would have been way too big. So that's perfect. All right, now we have to solve for 0. We know that's the equal 0. All we have to do is figure out when does this equal 0 and when does this equal 0. Okay, when does this equal 0? Oh, when x is negative 14. And if this is 0, 0 times whatever is left over here after I put a negative 14 in here is going to equal 0. So that will make it equal 0. So this equal x is one of the solutions that makes it equal 0. The other solution is I have to make this into 0. Here it would be a negative 3 equals x. See, some of these are going to be very obvious like this. Okay, we're going to be going over some in a little bit that are not this obvious. But these are really quick to answer. So those are the two solutions to this one equation. Solve the equation. Here it is. In this form, it would have been a lot of guessing until you got to these two numbers. Okay? Now we're going to be factoring this. This is the second form of factoring. This is when there's a number in front of the variable. Okay? Now you're going to do 2 times 12. So that's the first step. There's 4 steps to my knowledge. So 2 times 12. Now that is 24. This helps us answer the question of what two numbers multiply to make 24. See how I'm not pointing at the 12? Even though 12 is part of it because I went like this, 24 is the number we're thinking. After we do the first step, you no longer look at the 24. So what two numbers multiply to make 24, but when you add them, they make a 10, right? 6 and 4. So here we're going to be splitting the center into 6b and 4b, and they're both positive, right? You got to write what signs they are. They're both positive. And then everything else just brings down. So nothing happened to the formula. You can easily notice that if you put these back together, you'll end up with the same thing that's above. So you haven't changed anything. We just wanted to find these two numbers. Now your next goal is to put the front 2 in parentheses and the back 2 in parentheses. Now you're looking for a common divisor here. Well, they both have a b, so I'm going to be taking out a b out of the equation. And they're both divisible by 2, so I'm going to be taking a 2 out of the equation, which means everything gets divided by 2. So this leaves you with b plus 3, okay? Because the b goes away, and here it loses one b, so it's left with a b. Now here, our goal is to make this one look exactly like that one. If we do it correctly, they'll both be exactly the same. So we're going to factor out a 4. If we factor out a positive 4 out of this side, we're going to get a b and a 3. Seeing as though these two ended up exactly the same, I have done everything correct. So now, all I have to do is write this and that, the things outside of the parentheses, in one, and the other one will be what has been left inside the parentheses. And that is your final solution. You could factor out a 2 out of this, but this is probably what they're looking for. All right, pretty simple. Okay, it has one step that splits this, 2 steps finding the common denominator, and 3 writing it down. Okay, so if you put this as 1 step, that's fine, but if you want to do it 2 steps, that's fine. So you end up with 4 steps. All right, now let's look at this one. Again, we're doing the same thing. 12 times 5 is 60. So we're looking for 2 numbers that multiply to make 60, but when you subtract them, they make a 4. Okay? And same rule applies. The largest number that we choose is going to be a negative. Okay? And this negative sign means that they're different. So 60 is going to be 10 times 6, right? So 10y is going to be a negative and a positive 6y. Then we bring down the negative 5, bring down the 12y squared, right? Now we're going to factor this, and here we go. What do these two have in common? It's not a 12, it's just a 2. 2 is the only number I can take out of that. And they both have a y, so I'm going to take one y out. So I'm left with 6y minus 5. This over here is already 6y minus 5, so we're good. But I do have to take something out, so I'm just going to take out a positive 1, because if I divide everything by positive 1, everything goes away. So 6y minus 5. So I took something out, and it stays exactly the same, which is what I wanted. So now our goal is to write everything that's outside the parentheses, 2y plus 1, and everything that's inside the parentheses, which is 6y minus 5. All right? Again, the 1 step, then the 2 step, the 3, and then literally just write it, 4. All right, this one is solve the equation. So once we're done, we have to actually solve for 0. This might take a couple steps, but only if you're not good at solving a 2-step equation will this be an issue. All right, so 3 times 16 is 48. We're looking for 2 numbers that when you multiply, they make 48, but when you subtract them, they make a 2. Now those 2 numbers are 6 and 8. So 6 is going to be the minus, and 8 is going to be the other one. Now remember, the order doesn't matter here. You should get the same answer no matter what. But if you feel like one way was harder than the other, you should just switch them and see if that works out for you. Some people there's sometimes one way that's more obvious than the other. Okay, here we go. Equals 0. So now we're going to do this here, and we're going to do this here. Usually I put the sign in there. Remember to do that. Then these are both divisible by h, and they are both divisible by 3. This leaves me with h minus 2. And here they're both divisible by 4. Or no, they're both divisible by 8. So I'm going to take out a positive 8, and they're h minus 2. And there we go. So now these two are the same, which means I did it perfectly fine. And now I'm left with 3h plus 8 and h minus 2 equals 0. So all you have to do is make this equal 0. This one's obvious. The answer is 2. 2 minus 2. So h equals 2 is one of the answers. Now this one's not so obvious. So what you're going to do is bring it over here and write, when does 3h plus 8 equal 0? Subtract 8 on both sides. 3h equals negative 8. Divide by 3. Divided by 3. When h equals negative 8 over 3. And that's the final answer. I don't have to divide it. I don't have to make it fancy. You could make it into a mixed number if you want and write negative 2 and 2/3. That would be fine if you wanted to do that. But that's it. Those are the two answers. All you have to do is make each thing equal 0. So when does this equal 0? When h is negative 8 over 3. All right? Now we're going to go here. So here I'm going to have, you're going to factor this. Now the thing is, if you haven't noticed that all the factors we've done before have 3. The reason that this has 2 is because both parentheses are exactly the same, except for one is a plus and one is a minus. So when you see this, you just got a really quick shortcut. Very easy. And all you have to do is square root. So the square root of k, what times itself makes k squared? That would just be k. What times itself would make 100? That would be 10. I told you that both sides are exactly the same, so you do the same thing here, and you are done. So when you see two numbers and a minus sign, that automatically means that you have a shortcut. Very fast problem. Oh, look, it happened again. If there was a plus here, there would be nothing to factor, and you just say prime. But here, you can factor, because there's a minus. So there's two numbers and a minus, and so we're gonna do a plus here, a minus here, and we're gonna find the square root of this and the square root of that. So this is gonna be 2, this is gonna be x, and that's gonna be 5. So I just repeat the same thing over here, 2x and 5. Then here, we're gonna solve the equation. So here, these numbers don't have perfect squares. There is a minus, so there's going to be a shortcut somewhere. So what I'm going to do is factor what they have in common. Now, for a second there, I thought, oh, maybe they're both divisible by 8. Nope. Maybe they're both divisible by 4. Nope. So the only thing I see that they're in common, that they're divisible by, is 2. So if I factor out a 2 and I divide these, I'm going to get a 16 and an 81, which I know those are factorable. Now remember, we're trying to solve the equation. So when we're done, we still have a little bit more work to do. So 2 is still here, but now I know that I have one parentheses with a plus and one with a minus. This is going to be 4, and that is going to be 9k. Because 9k times 9k makes 81k squared. And the other one's going to have the same exact thing, 9k. And remember, this has to equal 0. So all we have to do is make this equal 0 or this equal 0, and we'll find our both solutions. So 4 plus 9k equals 0. I'll subtract 4 on both sides. We're left with 9k equals negative 4. Divide by 9, divide by 9. There's one of our answers. So let's do the other one. 4 minus 9k equals 0. I'll hold the paper at the same time. I'm trying to write this 0 very softly. There. Nope, it's going to move. So let's write it over here where I can actually write. 4 minus 9k, right? Is that what it was? 4 minus 9k, yep, equals 0. So you subtract the 4 on both sides. You're left with minus 9k equals negative 4. K equals negative 4 over negative 9. They're both negative. That means it becomes positive. So K equals 4 over 9. So those are the two solutions. One of the solutions is negative 4 over 9, and the other solution is 4 over 9. If you put these two equations into any of these problems, any of these three that we've been creating, because they're all the same problem written in different ways, you'd get 0. All right? And that's it. Good luck.